Good day to one and all. Today we will discuss about signal decomposition through discrete wavelet transform using MATLAB programming. In our previous videos, we discussed about signal decomposition through discrete wavelet transform using Python programming. Similarly, we also discussed about signal decomposition through discrete wavelet transform using MATLAB Wavelet Analyzer. MATLAB Wavelet Analyzer app. So this particular app doesn't need any programming to do. So there is no need of programming in this particular app when we want to decompose signal. So there is no need to write a program in this particular wavelet analyzer app. So both videos links are given in the description of this particular video. Today we will discuss about signal decomposition through discrete wavelet transform using MATLAB programming. So generate pure sine waveform using discrete wavelet transform up to 3 levels. So CLC, clear all. Now we have to give the time. So time is equal to some 0 to some up to some time. So 0 to 0.399 with interval of 0.001. So 0.001 is the interval. So now we have to give the main sine waveform function. So we know that y is equal to sine wt, where w is equal to 2 pi f. So 2 into f is 50h, 2 into 50 100, into 3.14, it is around 314. So y is equal to sine 314 into t. So now we have to plot this y with respect to temperature. So t with respect to t. So plot t comma y. So t is time and y is our sine signal. So now execute this program. So evaluate selection in command window. Now we will get the plot of pure sine waveform with respect to time. Now you can see here workspace, we have the y value here, y variables here. Now we have to save this y variable to our directory. Sorry, our MATLAB directory. So we saving it as pure sine wave and saving. Yeah, so we are saving this particular variable. Now we will decompose this particular y signal, so which is a pure sine waveform signal. Now we have to decompose the pure sine waveform using discrete wavelet transform up to third level. So now again CLC, clear all, and we have to import the pure sine waveform .mat file, which we already saved it in the directory. So now we have to import that one data. So x is equal to import data, which one, pure sine waveform .mat file. So with this one we already generated the signal, and also we have saved it in the MATLAB work directory. So now we are importing that data here to decompose that particular signal. Now we have to decompose this particular signal x. So C comma L is equal to. So there is a one command to decompose the signal through wavelet transform, that is wave deck. So wave deck bracket x is the signal, comma level of the decomposition 3, and we have to give the whichever mother wavelet we have to give. So we are using here Dabuchi 2 db2. Now we have to extract the approximation coefficients of a signal. So approx is equal to app coef bracket c comma l comma particular mother wavelet db2. So now we decomposed the signal, pure sine wave pure sine waveform signal, which we can see here. Now we extract the detail coefficients, individual decoefficients at each level. So CD1 is the detail coefficient of level 1, and CD2 is the detail coefficient at level 2, and CD3 is the detail coefficients of level 3. So is equal to DET COEF, so detail coefficients bracket C comma L comma 1 2 3. Now we have to plot this entire each detail coefficients and approximation coefficient and main original signal pure sine wave form. For this we have to write a command called as tiled layout. Tiled layout. So TI LED LA YOUT, tiled layout. So TI LED. So T is the wrong here. So TI LED LA YOUT. So we have at least 5 columns because original signal CD1, CD2, CD3, and approximation. So totally 5 columns we need. So next we have to write next title, and we have to plot the CD3 here. So plot CD3. So you can plot first approximation coefficients, plot approx. Next again, we have to give the title. So title is approximation coefficients. So next we have to again go to the next level of coefficient. So again next tile. So next tile it create access in the tiled. So again we have to give plot CD2, plot CD2, CD3. So CD3 is the third level of decomposition. The third level of detail coefficient. So level 3 detail coefficients. Level 3 detail coefficients. So again next tile. So plot CD2. Title is level 2 detail coefficients. So next tile, so this time plot CD1, so which is level 1 detail coefficients. So title is level 1 detail coefficients. So next tile. So now we have to plot the pure sine waveform, pure sine waveform. So original signal. So plot x. So which is a original signal, which is a pure sine waveform. Plot x. So title is pure sine waveform or original signal. Title is pure sine waveform. So this is the program. So now we have to execute this program to get the decomposer sine waveform. So right click, evaluate selection. So there is some error is there because we have given a mistake in the eighth line. So it is a title layout. It is a tiled layout, TILED layout. So now we again execute this program. So this time we will get the particular approximation coefficients and level 3 detail coefficients, level 2 detail coefficients, and level 1 detail coefficients of the pure sine waveform. So we have got a five sine waves in a single plot.